So I'm going to share my screen now, then we start the lectures. Again, if you have a question about how to use my workbench, I think we did that example here. So this video last week, I think it is this Monday. This video here explained my workbench. Or you can also go online, go to YouTube, type how to use my SQL workbench. You get a lot of videos from everywhere, many sources explaining it. So today I'll go through, and again, if you have a question about how to use the workbench or any question you can ask, and I will go through the steps one more time. So today our main objective again is to review some of the SQL scripts that we went through. As I said earlier, I'll try to go as slow as possible. Then we start. The next slide will be our new topic for this week. So first, we talk about what is a structured query language. This will be a standard language for communicating with a relational database system. Also, we can use it to create a relational database or database system. And here they give us the history of the SQL, which I'm going to skip for now. We went through this. Now, the purpose of SQL standard, I would say the main purpose here is that if you have different vendors, for example, in computer science, we may have 5 or 6 companies producing their own database system or their own hardware system. If there's no standard among all these products from 6 different vendors, what will happen? They cannot communicate with each other. We can't even use any application on the internet, because on the internet, we have millions of different computers with different platforms, etc. So there must be some standard of communication so that things can work. So SQL is a very good standard script language for relational database system. We can use it for MySQL, we can use it for Microsoft Access, we can use it for Sybase, Oracle. So there are so many different databases which all use SQL. So the benefit of having a standardized system, of course, is to reduce training costs. Because if we know different vendors have a different standard, then most likely, if I'm moving from one vendor product to another vendor product, I need a training. But if all the vendors are using the same language, a standardized language, then training costs will go down. Also, to improve productivity and also application portability. And I think this is the main advantage. Portability means like the internet, we may have a laptop, a desktop, different computer architectural platform, but they can communicate with each other. And they are portable. And also reducing the dependency on single vendor, because here we have a standard language for all the vendors. So the SQL environment, as we said, this is just a few terminology, but we know in the SQL environment, we have 3 different sections. We have the data definition language. These are the commands that we can use to create the database and also the database objects, such as table, views, and index. Then data manipulation language. This is the section we can use to question our database system for some answers that we need. So we call it query. I will query my database. For example, I need all the customers that spend over $1,000 a month if I have a customer database system. Then we have the data control language. And data control language is for security, I would say the administrative work. So for example, a company like a College of Rochester, they may have the president of the school who have access to everything. They have access to the accounting, the human resources, students' information, both in terms of academic records or financial records, they have access to everything because it's the highest command. You have to know what's going on in general for the school. But let's say, for example, I'm a teacher. I don't care about the accounting issues in the school. I'm not responsible for. My responsibility is to teach my students in my class. So most likely I don't have access to the school, even to the students' financial aid. I don't have no access to that information. So this is something we can use the data control language to give the privileges. Privileges means to have access and be able to use some data related to your work. So those are the three major parts of SQL environment: data definition language, data manipulation language, data control language. Most of the time we are going to focus a lot on data manipulation language. Data definition language, we don't use it too much because if I'm working for a company, I already have I create a database for the first time. I create all the tables I need, all the views. So maybe once a while, I may use it to add more tables or index in order to improve the performance of my database. When we say the performance of the database, we mean how fast we access data or how fast we can process the data information in the database system. So index can help us a lot to faster to access data. This can be done using data definition language. Then data manipulation language is where we do a lot because we want to analyze our data, how the customers are doing, how the market is. We want to know some few things, so we're always going to use query a lot. So we know the word schema in MySQL means a database. A database. The catalog will be a set of schemas, a database that constitute the description of a database. So it's kind of like a metadata, data that explain data. For example, I may have a table, but I may have a description of the table, that this table we can store customers' information. The customer ID should be only 4 digits, the data types should be number, etc. So this is the environment of SQL. Most companies, we know we have a networking system, we have the client and server. The workbench we are using, MySQL workbench, is kind of like our server, but again, this is a learning environment. So you store it in your laptop using it. But in the real world, you may have a big server, a big computer as a server, and all the other workers' computers, which we call the client, like a users, they are connected to the server. So when you want to store a new application, you store it in the server. So in order for the user to get access to the server, maybe for security reasons, we don't want anybody to get access. So we might get some restriction whereby you have to authenticate, like having your username, password, to be stored in the server. So when you enter it, the server will, okay, if you match, you have access to it. So first we start with the SQL data types, and we discussed about this already. We have a string data type, which will be either one or more characters. So for example, by default, we may have char, which is a character. Here we say it can store string values containing any characters in the character set. So char is defined to be a phase length. Then we can have the varchar. Varchar, you can specify the length of your characters. Let's say I can have a parenthesis say, and it's up to 30 characters. Then if I'm storing an object, let's say an image, we also have what we call the binary large object. This will store binary string values in hexadecimal and also BL, OB, etc. This is used in Oracle, etc. We have number, data type. It can be integer, it's the same as we say a whole number. We also have a temporal. Anytime we use the term temporal, it means it goes with time. So sometimes we have something called a temporal data, which means a data that goes with time. Like a good one would be like the stock market. We call it, also use the term time series data, which means most of the stock market data, the prices go with time, because with time the prices changes. So always, if you are plotting a stock market data on your, let's say, graph, always the horizontal should be a time period. It can be weekly, daily, whatever time period it is. We also have the Boolean data type. So temporal data type is about time. So these are all the SQL, three different environment, the DDL. This will define the database, as we said earlier. So example of a command would be create tables. So we must say create tables, then we have the table name. After the table name, we open a parenthesis, then we list all the columns. The columns you can have, let's say, when I say list all the columns, I mean the characteristics of the, for example, if I have a table name student, one of the field or the column name can be student last name or ID. So I may have the name student last name. The data type will be string or text because it's characters, or we can say varchar 30, which means it can take up to 30 characters. Now, if I want to make it primary key, it's up to me. I can make sure it's not null, etc. We'll go through that today again. So we can also establish foreign keys. We talk about foreign keys. If I have two or more tables, I can create a relationship between the two tables, which means I need a foreign key. A foreign key is a key that is a primary key in another table. And the purpose of a foreign key is to be able to create a relationship between those two tables. We can also drop a table, which means you are deleting the table altogether. Then we have the data manipulation language, which is the DML. Example will be mostly writing queries a lot using the select. That's what we said, using the select command a lot. We can also insert insert command is to enter records into the table. If I want to update, means I want to change something, some record in my table, I can use the update command. Then the next one is the DCL, data control language. This is to control the database. Example, these are all, the grant is like a privilege. I give you permission to do something or to have access to some data, or I will revoke it. I don't give you access to that data no more, or had you, etc. So we can see on the right side, DDL goes with the physical design, because this is where we create our database, the table, all the items. And also it will need a maintenance as time goes on. DML is basically implementation, adding things, removing things, selecting things, etc. That's all implementation. Then DCL can be implementation, but at the same time, we also have to maintain it. But DML, we don't maintain. So we start with the data definition language again. And here we said every time we are creating or we want to do something on MySQL, we have to have our database already. So if you don't have a database, here we are using the workbench. Then we can either, I think we went through that on Tuesday or last week, Wednesday. We can either use the mouse, like graphical user interface, just right click, then you click on create schema, then you do everything graphically without writing no command. You don't need a command. We went through that. But in this course, we want to do everything. Everything we want to do, we want to use the command, because that's what we are learning in this class. So the first thing is to create a schema. MySQL, you can use create a schema, but again, the universal word, we will say create database. So you write the command create database, then the database name. Then we also use the create table command, which will define a new table and its column. So when I have create table, I think we're going to see example again. So for now, Let's know the command is create schema or create database, which will create a new database for you. Create table will create a new table. Then also create a view or create view. This will create a view for us. This defines a logical table from one or more tables or views. And we'll discuss more detail on views. One of the advantages of a view is that I can create a query and I can create a view from that query to have the data there and easily to access it very quick also. We have other create statements like character set, correlation, translation, session, domain. We may go through all this. Actually, we haven't gone through most of this. It will be later in the semester. So what are the steps in table creation? We discussed this already when we went through the beginning of the lectures and how to design a database, how to use the ERD diagram or the ER diagram, entity relationship diagram. So that's the steps here again. First of all, if I want to create a database, I have to know what kind of company I'm creating the database for, because every company may store different data. For example, in a bank, they may store different data than if for educational institution. Educational bank don't deal with students. And school also don't deal with customers. Most, I'll say the customers are students. So we have to identify the data types for our attributes, what type of data. And also the entity, we need to identify the entity. The entity later becomes the table. Then we should identify the columns. We should also identify the primary key field or the foreign key, which we call the candidate keys. So primary key, foreign key. Then we can also determine a default value so that we don't have to be wasting time to enter that value always when we enter a new record. So for example, if I know I have a company, all my customers are from New York, then if I have a field name state, I will just put a default value there to be NY. So anytime I'm going to enter a new record in the state, the NY is waiting for me. I don't need to enter it. So that's default values. Also, we should identify some constraints on the columns. The constraints will be many examples. So a very simple example can be age. We know that a person cannot be more than 150, 200, or 1,000 years. So if I see a column and they say the person age is 1,000, I would think there's mistake. Maybe they added 2 zeros or 1 zero. Some people can reach 100. So we can say at least they added 1 more 0, 2 zeros. So we can know constraint. Example also gender. Gender, we have to make sure we can set our rules that you can only enter male or female, which will be M or F. We discuss about that. Also, we can create a table and the associate indices. So after we identify all these elements up to 6, then we create a table. Then if possible, we can create indices. Indices is basically to be able to access the table very quick. So now this is the command to create a table. We have create table. Database command is very straightforward. Just say create database, then the database name. That's it, we finish. Then you can end it with a semicolon. Now, if we want to create a table, we use the command create table. As we mentioned earlier, every time you are writing a script language, you write the command as a uppercases. Then you can write the names as a lowercase so that it will be easier to read. So yeah, no, create table is a command. Then I have to give my table name. After that, I'm going to open a parenthesis. Then I'll define all my columns. That's my field. If there's any constraint, I will add it here, like foreign key or the data types, everything will be here. Now we can also have what we call the on commit delete. We may discuss what this means later on. So example of a column name, again, can be the domain name, let's say student last name. And the data type can be varchar. The size is 30, which means we can put up to 30 characters. And if there's any constraint, we can add it. If there's any default value, let's say if it's a state, we can make default value as New York or any state that we think is common for all the items, or male and female also, we can make default value for gender, either male or female. So the following slide will create tables for this enterprise data model. So here we have customer, product, order, and order line table. This is a ER diagram. So here means one-to-many relationship. And as we said earlier, when we went through the ER diagram, always the relationship is a verb and the entities or the tables is a noun. So a customer is an object now. But here we are having a relationship that one customer can places one or many orders or order. One or many orders. So here we say customer places many orders, or many orders is placed by customer. So normally we get this relationship from the business rule. So if the database, for example, in a school, we may have a database system for the school, let's say College of Westchester, and they said that one student can take only one class because the semester ends in 4 weeks. Or one student can take up to 2 classes because the semester ends in 8 weeks. Or one student can take 3 or more classes because the semester ends in 16 weeks. So if I have that business rule and the school have only 4 weeks per semester, then the relationship between student and course will be 1-to-1, because one student I may have the verb take or register. So one student can take 1 class. If the semester is 16 weeks, then we can say one student can take 1 or many classes. Normally, many can be more than 1, 2, 3, any amount. So here we have a table named customer. We have only 2 fields, the customer ID. We underline it because the customer ID is the primary key field. Then we have customer name, product ID, primary key field, standard price, then order line, we have quantity. Then the order, we have order ID. Order ID will be a primary key field, but there's a relationship between these 2 tables. So we have customer ID. Customer ID is a secondary key or foreign key in the order table, but it's a primary key in customer table. So let's see the code. So here we say create table, customer T, that's the name of the table. The command is create table, customer T. Then we have all the fields. So you can see we open the parentheses and at the end we close the parentheses with semicolon. So first we have how you arrange these fields is important, because when I run it in my table, it will show the first field first, second field second in columns. So first I have customer ID. And the data type, we say it's a number. And we say the number have 11,0. What 11,0 means, we can have up to 11 digits, the size. 0 here means there's no decimal place, no decimal place. Now I can put 2 here. For example, if it's currency, I can put maybe 4, or we still can put 11. Maybe there's somebody have billions of dollars, but maybe most likely to be around 100,000. So we put 6 and we put 2. Actually, we put 8 because 100,000 means the whole number is 100,000 with 2 decimal places. So we put 8 and then 2, which means we can have 2 decimal places. Now, because later on we are going to make customer ID as a primary key field, we put not null here, because anytime we have a primary key field, you have to enter something. Not null means if I enter the record, I need to enter something for customer ID, because that to uniquely identify each record. Also, we make the customer name not known, because if you don't enter the customer name, we don't know who the customer is. But the customer address is okay. If we don't have the address, it's fine. The city, the state is okay. The postal code is okay. Then all of them are characters by different size, or we say strings, different size. Then now we are making customer ID as a primary key field. So we use the keyword constraint. Our constraint is here is primary key field. So we name, when we create a primary key field, we give it a name. So customer PK is just the name that it can be any name. This is the name that they invented or the person is using. You can use any name. But the keyword primary key with the argument of the customer ID, whatever field is here, is that field will be the primary key field. So in this case, it's customer ID. So I'm going to wait for a few seconds if any question. Again, if you have a question at any time, you can just interrupt me, stop me. So I won't go through all this table. If we have a new command, I think it's the same thing we are repeating. Create a table, order T, order ID, order date. Because, okay, here we are creating a foreign key also. So why do we create a foreign key? When we look at the last command here, there will be a relationship between the order T and also customer T, because I can see that the customer T, the primary key field is customer ID. Then the customer ID is inside the order T as a foreign key we are creating. So here we have the constraint. We create our primary key as our order ID. But we also have another constraint where we are creating a foreign key, and the foreign key will be the customer ID. So this will lead us to create a relationship between customer T and the order T. So the first constraint is the same as customer T. We say constraint, the name of the primary key field, customer PK will be the name of the constraint. Then we have a primary key as the customer ID. Here the same thing, we have a keyword constraint again. This time the name of the constraint is order PK. We are creating a primary key, and the primary key field is order ID. But next we have another constraint. This time the name is order FK. We are creating a foreign key. The foreign key is the customer ID. A foreign key is always a primary key in another field. So if customer ID is not a primary key field in a customer T, we will get an error. So we have customer ID. Now, when we have the foreign key as customer ID, we use the keyword references. These two references to the table that we are going to have a relationship with. Right now we are in order T. Order T will have a relationship with customer T. So the references will be to customer T, and the customer T, customer ID, primary key field. So we are creating relationship between these two tables, order T and customer T, using the customer ID. I'll wait for a few seconds if no question. Okay, so the same thing in product T. We have the same creating product T. We have product ID, product description. The new thing we are doing here now is the product finish. Product finish, we use the keyword check. This will tell us some items that the command here telling us the input or the item we can enter into the field name product finish. So product finish, the data type is string or varchar. The size is 20, which means we can enter up to 20 characters. But now we are saying check product finish, again, the attribute name in. These are the possible values we can enter. So I can do the same thing for gender. I'll have a gender, the varchar will be 1, maybe just make it char, only 1 character. Then I'll say check gender in male, I'll put male in a single quote, then comma, female in single quote, then cross it, which means I can enter only those two fields. Here it means in the product finish, we can only enter cherry, natural hash, white hash, red oak, natural oak, and walnut. If I try to enter any word which is not here, I will get error. Actually, I won't be able to enter it. It won't accept. So I think that's the only new thing we're learning here. If you have a default value more than one and you want to enter it yourself, there's another way of entering the default value, only one default value the system will enter for you. So we also have a product standard price. So yeah, this is what I'm saying. So for example, product standard price, we say is decimal. We have 6 and 2, which means we can have up to 6 digits, but the last the 2 digits will be decimal. So we have 2 decimal places. So the same thing applies to the create table also. Since we went through we know how to create a primary key, foreign key. So that's it. Okay, if no question, let's keep going. So now we'll go through each one step by step. This is create table product T. We have the fields or the column names, product ID, the data type is number. It take up to 11 digits. There's no decimal. Also not null because we always have to enter value in product ID. Next is the product description. We have the data type to be varchar 2. The size is 50, which means we can enter up to 50 characters. Product finish, we can enter up to 20 characters. But with product finish, as we said earlier, we have values that we have to enter. These are the values. So we start with the keyword check, the name of the column, which is product finish, in. These are all the possible strings or words that we can enter. Then we have the product standard price. The data type is decimal, 6 and 2, which is 2 means the 2 decimal places. Then we have product ID, we say it's integer. Then our constraint is the primary key. The product ID becomes the primary key field. Okay, if no question, we keep going. Now, also we said sometimes we may have what we call the non-nullable specification, which is right here. And normal, as we said, a primary case can never have a null values because a primary key field is the field that uniquely identifies each record. For example, student table, we may say student ID is the field, the primary key field. Back in the earlier days of computers, as a student, they used the social security as the primary key field. When everything was not online, it's manual. Somewhere in the 80s, early 90s, when you go to school, they don't waste time to give you an ID. Most schools will use your social security as your unique number to identify you. But when information starts to go to internet, which we know many people can have access, social security is a very important data for each person. And they stopped that. So most systems now use the unique ID number for each person or student. So if no question, we keep going. So here also we have the non-nullable specification. The primary key field, we have order ID and product ID. And we can see that order ID and product ID, they are not null. Here, what we're trying to say is that sometimes you may have a table and only one field cannot uniquely identify the record. So you may use 2 or more fields as a primary. In this case, we are using 2 fields, order ID and product ID as the primary key field. It's possible. And normally we use the term composite. That's some primary keys are composite, composed of multiple attributes. Now, how do we control the values in attributes? That is the data types, as we said earlier. So either we specify the data type, or in this case, the order ID is the data type. Order date, we can say, okay, by default, we are using the system date. A sys date means the computer date. So anytime I enter a record or do something, the order date here will be the date that the computer generates for you. That's why it's a default value. I'm not going to enter it no more. Or sometimes we can set a domain constraint. Here we say, okay, the input can be only this value. Here we did it. We use check command with in to create the values that we can enter in product finish. Okay. Next, we saw there how we came up with the foreign keys. So as we said earlier, foreign key is normally good thing, very good thing, because anytime we want to, the reason why, one of the advantage of relational, that's why it's called relational database system. Relations can be table, relationship, maybe 2 or more. Is that, for example, if I have a customer table and also I have a vendor table or I have an inventory table, if there's a relationship between customer table and inventory, what will happen is that anything we do in inventory, it will be updated in the customer table, or anything I do in the customer table will be updated in inventory. So relationship, or in this case, when you have a foreign key and establish a relationship, it reduces a lot of redundancy. I don't want to update customer table, then I'll go and update vendor. Most likely, if the two didn't match, then we have inconsistent data in our system. So relationship is very important. It reduces redundancy in some ways and also make sure our data is consistent. What is in one data, the update is correct in another data. So in order to create a relationship, we need a foreign keys, as we said. So here we have a table again, the customer T, and we want to create a relationship between customer T and the order T. So which means in the order T, I'm going to have customer ID, because customer ID is a primary key in customer T. So I'm going to have it in the order T table as a what? Foreign key. Some books use the term secondary key. In this book, we are using the term foreign key. So as we said, if you want to create a relationship between 2 tables, you have to use 2 primary key. But one primary key becomes a foreign key because it's a primary key in another table. So when we look at the create table order T, we can see that we're creating the last constraint order FK. So that's the name of the constraint. We are creating a foreign key, and the foreign key field name is customer ID, which is a primary key in the customer table. And we are going to references, because sometimes what will happen is that I can have 2 tables and they are using the same field name, but they are in different tables. So we have to specify the table. This customer ID is in a table called customer T, and that's where we're creating. This statement will create the relationship for us. And it's using the customer IDs. We have customer ID now in the order table, which is right here, the third. So we're creating the relationship from customer ID and order table with the customer ID in the customer table or customer T. So this, the few command we went through basically is how to create tables and also establishing relationship, the foreign key. It's kind of a review, but again, it's good that we should go through this one more time and we continue forward. So here we said data integrity controls. And this is what we were talking about, consistency of all the data in all the tables. So again, in relational database system, we have something called the referential integrity, which can do three things for us: delete, update, and insert. When you are doing deleting an item, you are going to update some things and update and also insert. Things will change. So if I have a record and I delete something, the state of the items in that table will change. The same thing if I'm updating something in my table, the state of it will change. Also, if I insert something in my table, the state of it will change. So for us to make sure that when they change, they will be very consistent and no error, we have to enforce what we call the referential integrity. A very simple example would be like in Amazon. This company have millions of customers around the world. Two customers can place order of the same thing at the same nanosecond, not even a second, a nanosecond at the same time. So how do we make sure that the update will be accurate? Two or more customers placing something at the same very second or nanosecond. So this is where the referential integrity will do its work. So here we say referential integrity is a constraint that ensures that foreign key values of a table must match the primary key values of a related table if we have one-to-many relationship. And to make sure that it restricts the deleting of a primary record. So if you have a primary key and also updating of a primary records and insert of dependent records. And we will go detail on this. So for example here, ensuring the data integrity through updates. We have a relationship between two tables here, customer and order, one-to-many relationship. Now we say we are going to restricted update. Here we say what? Remember, customer ID is a primary key field, so that's what they put here, PK. And the customer ID is a FK, that's foreign key in the order table. So we have two relationships between these two tables. So now here we are saying that the customer ID can only be deleted if it is not found in what? The order table. This will be one of the rules that the referential, we call it referential integrity. So here we say relational integrity is enforcing through the primary key to foreign key match. So in order to delete, unless we don't have it in the order table, the customer ID in the order table. So here we have create table, customer T again, then customer ID. We set the integer default value to 999, not known, the customer name, voucher, 40, also not known. This is just example. Let's say we have these two fields. Now we create our primary key field as customer ID. Then we have on update restrict. So this is the main keyword here. We make sure that again, we are enforcing what we call the referential integrity, which say these rules for us. We cannot delete primary records, update primary records, or insert of dependent records if there's a relationship. Also, we can do what we call the cascaded update. That's changing a customer ID in a customer table will result in that value changing also in what? The other table to match. So they have to be consistent in the two relationship. I'll wait for a few seconds if we have question. So that's the update cascade, making sure if we change something in one table, it should be changed in the other table if they have relationship, and that always happens. Otherwise, we are going to have inconsistency in our data. We also have to set a null update. When a customer ID is changed, any customer ID in the other table that matches the old data ID will be set to null. We don't need it no more. relationship. And that's called the on update set no. Then we also have the on update set default. The whole goal here is again data integrity or consistency in our database system, especially when there's a relationships. And we must have a relationship, because if we don't have no relationship, we are going to have a lot of repetition of the same information in two or more tables, which is not a good idea. So the next, if we want to change items or want to change tables, let's say we want to add a new column or records or something, there's commands for that. So for example, we can use the command AutoTable. So AutoTable statement allow you to change column specification. So for example, or we can even add. So here we say AutoTable, the table name, then whatever we want to do. So for example, I can add a new column, or I can change. When we want to change, we use the set. For example, here we say add a column, but this is adding a new column. So we write the column definition, the name of the column. But also I can say auto column, the column name. Then I'm going to set a default value. So I use the command set default, then set it to any value you want to set it to. Let's say if it's a state, I will set it to New York, NY, if all my records or customers are from New York. So I don't need to type it always. Same thing, if I have something on my table I don't like, I can use the drop also. So in this case, we want to drop the default. So I can say alter the column name, then drop the default. Also the cascade, if I want to drop it, we can also say drop whatever the column name is, then we restrict cascade. So a good example here, let's say we have a table already called customer T in our database. So here we say AutoTable, the table name. Then here we are adding a new column. So we say add column. The column name is customer type. The data type is voucher, and it will take only 2 characters. But the default will be commercial. Same thing, we can remove tables. Removing table means, again, you want to take it out of, delete the whole table, not the records, but delete the whole table. We can use the command delete to delete records from the table. But drop table statement allow you to remove the tables from your schema or database. So if I say drop table customer T, it means I want to delete all the table, everything, including the table itself. But if I want to remove a record from the table, then I'll use the command to delete. We also have the command to set statement. So this will add 1 or more rows to a table. So this is a very nice example. Insert into customer T values. Now, when you write here the values that we put here will go into the table in order. So here I have to make sure that the data types here are the same. So for example, if my first column is let's say it's a last name, and the last name is a string or voucher, I will get an error here because 001 is a value, it's not a string. So when you use insert into, then the name of the table you are setting it to, and the keyword values, and open parentheses, and you enter all these values. Every field value, we have a comma with space between. If it's a string or character, we put a single quote on it. If it's a value, you don't put anything. For example, the first one is 001, we don't put no quotation. This is a string. The rest are strings. The zip code is also a value, we don't put no quotation. Sorry. Yes. call the person later. Oh. So again, that's how it is here. Then now, if I want to enter values into my, I want to turn the phone off. So if I enter a value into my table, but the values I'm enter, not in the columns are not in sequential, maybe I will miss some columns. Then in this case, you have to specify the field. So for example, here we say insert into product. You can see that instead of writing values, we start with the names of the columns. Product ID, product description, product finish. So all the values I enter here now will go to only the fields that are shown here. Those are the items that will go to those fields. And it will start from number 1. So product ID will be 1. Product description will be end table. Product finish will be cherry. Product standard price will be this also. So that's the difference between the two. If I'm going to enter all the value in all the columns in my table from the beginning to the end, then I don't have to specify the column names. Also, another example, we can insert from another table. So we discussed a little bit about selection statement. This is one of the advantage of select. We use it a lot, and we will see a lot of example. So for example here, I want to insert an item into a table name CA customer T. But what happened is that the information that I want to put, first of all, I have to create this table. So you use the command create table CA customer T. But the information that I want to store into this table is already in another table. So what I'm going to do, I say select asterisk means all. So I'm going to select all from customer. Okay, so the information is in customer T. I create a new table CA customer. And the information I want to put there, they are in my customer T. So here I will say select all from customer T, where the customer state is California. So this means this table will have only customer informations, and that customers are only from California. So that's why we have CA customer. So insert into CA customer underscore T. Then we say select all from customer T, where customer state equal to California. So if we execute this, we are going to select everything in a customer T where the state is California. So only customer from California, we are going to put all their data into the table name CA customer. So we can also create tables with identity columns. So here, for example, we are creating a table customer T, but we specify that the customer ID integer generated always as identity. What we mean is that when you create the customer table finish, if I want to enter a value, the computer will generate the values for me. So if I say here, for example, we are starting with 1. So which means the first record I will enter into my customer table or customer T, the customer ID will be 1. And we are going to increment it by 1. Now, if I say I will increment it by 2, it means the next value will be 3, next value will be 5, next value. But here we're incrementing by 1. Then the minimum value should start 1. We don't go more than 10,000, so the maximum value will be 10,000. There's no init cycle. So the new bold statement here, the main goal of this, it is the same customer T that we create. But the customer T we create before, the customer ID, we have to enter it. We have to enter the number. But here, we don't need to enter the number. But rather, we will start from 1. Then we increment by 1. Then we keep going, keep going. The rest from customer name to the end, we already went through that. This is the new thing we are learning. If no question, we keep going. So next statement is delete. As we said earlier, there's a difference between delete and also drop. So drop means I want to delete the table. I want to remove the table. But if I use the command delete, it means I want to delete records from the table. We still have the table. We just want to remove some records from the table. So here we say that delete statement will remove rows from a table. It will delete certain rows. For example, here we say delete from customer T, where customer state is HI, Hawaii. So this means all the customers from Hawaii or HI will be deleted from the table. But the table and other records will be there. So for example, if a customer is from New York, we still have it in the table. Or we can say, okay, delete everything. So I can say delete from customer T. Here, I don't have any condition. So this means I'm going to delete everything from the customer T table. So next is the update statement, if no question. So here we are going to, update means to change or edit something, or the good term is modify something, or modify the data. So for example, here we say update. What we want to update, the place that it's located is the product T. So we are going to update something in product T. And we are going to set the product standard price. So that means product standard price should be a column name in the product T. And we are going to set into 775. The 775, if we want to set all the product standard price to 775, we can hand it here. But we have a condition that we only want to set the 775 price to the records that the product ID is 7. So anywhere I see a product ID is 7, I will set its product standard price to 775. But since product ID is a primary key field in the product T, when we create this table earlier, this means 7 will be only 1. So we are setting the record with product ID number 7. We are changing the standard price to 775. We also have what we call the merge statement. And actually, this is part of the materials we will cover in Module 5. We are going to cover in Module 5. So again, we can go through this. I think it's almost time now. Then hopefully I will continue this slide next week. So here we have a merge statement. A merge statement does what the meaning of merge means to, again, combine some things together. So here we have a statement saying merge into. This is the command merge into. And we are going to merge it into product T, which is our table name product T. When we merge it, we want to change it as plot. So we change the name as PORD. Then we have the keyword using the following informations. So the information, we are getting our information from this select. So here we are going to select the product ID, product description, product. If we are selecting all the column, then I can just write select all with the asterisk. But here we are selecting selected product, the column name. So we have product ID, product description, product finish, product standard price, product line ID, and we are selecting all this from purchases table or purchase T. Now, when we select all these items from purchase table, we are going to have it as PURCH. That's the name. Then on PROD.product ID. remember the PROD, now we have a table because we say merge into product T as PROD. So PROD is the table that have product ID. Should be same as PURCH dot product ID also. So this is the statement for merging, joining. And here we say when match, then we should update the prod, the standard price equal to the PURCH dot product standard price. We have the PROD and also we have PURCH. PURCH came from the purchase. We should have a purchase table already. So when we select from purchase table, we name it as PURCH. When we select from product T table, we name it as PROD. Now, if they match, but when not match, then we should insert product ID, product description, product finish, product standard price, again, all the columns again. In this case, the values for PURCH dot the product ID, PURCH dot product description, product finish, product standard price, and also product line ID. That's if the two doesn't match, we insert the values from the PU, which the PURCH is the purchase T, the information we get from purchase T. Then the key word we should know about us is that us will create a new table for you. So for example, I can have a statement that selects, let's say, I call from a table as table 2, which means after I select everything from one table, I'm going to put it in a second table, which is a new table I'm creating, like alias. I'll use the term alias. We also create alias, change the names. For example, I can write a command with SQL, and I may have a function, maybe to sum something. When I sum everything finished, I get a new price or new value. I don't want to store that value in the same column, so I can say as a new column. So which means you're going to create a new column in the same table and put the value there. And we will go through something like that also. So here they say it makes it easier to update a table, allows combination of insert and update in one statement, and also it's useful for updating master table with new data. We will go through merge statement more detail on theories, but this is just an example. We can look at it. We're almost done now, but let's see if we can finish these slides. I thought we can. Oh, we're almost done. Okay. We have 15 or so, but I think some of you have a class already. Again, I'll try to finish this section, then that's it. We still have like, I think only 5 minutes or so, 3 minutes. So schema definition, I think we went through this already, but just do a quick theory here. So schema definitions, we can have a control processing, storage efficiency. Now, if I have a database system and I want to have efficiency in terms of accessing the database or the storage, one of the main reasons they tell us here is the choice of using, we said indexes is very good because indexes increase the performance of the database by increasing the speed in the access. So choice of indexes and file organization for base tables, file organization for indexes, data cross-storing, and statistics maintenance. We may discuss all this. Again, I'll give a theory on this hopefully in our next class. Also, how to create indexes, we will go through that also. And I'm going to end somewhere. So from here going, we already went through this, but again, hopefully we may go through one more time. So I'm going to end somewhere here, unless we have any question. Okay, seems like no question. It seems like we have some students that just came in. So what I'm going to do now is, again, I'm going to pause for a second, then I'll take attendance. I'm not sure if the file is big, That means I cannot post the file in my, why this thing's not moving no more? Okay. If the file is too big, I can't post the video straight into the classroom. So I'll post it to my YouTube channel and post a link. So because of that, we have a lot of copyright issues online so I don't want the school platform to show up in YouTube. And also I don't want people faces or voice to show up in YouTube unless you don't mind. So I pause it and now I'm going to take attendance. I think we got some students. Fabian Kiara, Matthew Joseph. I thought we have increase of students.
I'm here.
1, 2, 3, 4, 5, 6. I have 2 students more. What's your name, please? What is your
Kiara
name,
Fabian.
please?
You just said it, Kiara.
Joseph Matthew. Kenny Javier. I think we should have one more. 1, 2, 3, 4. I hope everybody is sitting on the desk. But again, that's up to you. Your own, how you learn. Lobs Gabriel. Well, I have eight attendants. Okay. Okay. So we have 2 absent. That's correct. Okay. So one thing also is that you can see that we are repeating some of the materials over and over. The goal is that I want us really to understand the basic, because when we start to write indexes, views, and joining and subqueries joining, you see, actually we can see from here right now. Let me go back to the last slide about merging. Well, if you don't understand the simple create, select, I don't think there's a way we can understand the merge statement here. It's impossible. You can't understand, because when you are merging 2 tables together and trying to manipulate the data, if they are the same, put it in one side. If they are not the same, put it in a different table. Well, you can see that this command is more than 10 lines. So if you don't understand 1, 2 simple select, 2 lines, 3 lines, then it's impossible to understand this. So please, you want to gain the knowledge in this class, make sure we understand the basic concept. Then we continue. Where's the class? So we will continue again next week. So next week is like we will start module 4. Actually, we're almost in the module 4 now. After the merge, we do a little bit select statement, then we move straight to sub queries and then join together. So I'm going to post these slides. Maybe you may, again, what we just did is some of them are these slides. This is what we did on Monday. And also, just for your information, the video here is for how to create a workbench. How to use the workbench to create a database is here also. So most likely I'm going to post this video, not in module 5, but rather in module 4. And hopefully, if no question, then I think I'm going to end here. Sometimes I always miss with the time. Let me look at the time again, whether I have it right or wrong. Oh, it's supposed to be 1:45. Okay. See, no, I think, let me see 1 second. And the syllabus is the official time. Maybe this is the first day I missed the class. Oh yeah, 1:35. Yeah, that's what I know. 1:35, not 1:40. Because the class is 1 hour, 30 minutes. It's 3 credits, so we meet 3 hours a week. So I think I'm going to end somewhere here. I don't need to continue. It's almost time now. I'll wait for a few seconds if we have any question. Again, you will see this video in the classroom. There's so many videos now. Please do your best. Look from module 1 to 3. Make sure you understand everything. And also a little bit of module 4. Make sure you get it. So if you haven't done that, we have three students that didn't do the midterm exam yet. If you haven't done it, then again, make sure you do it. Previously, we have like 2 or 3 absent. So let me just open that section then. we face. So when you go to module 3, where I am now, it's still released. I haven't hide it. You should see it. It's still showing. So this is the midterm exam. If you click on the midterm exam submission button, this is where you are going to submit it. You create midterm exam instruction. This is where it is. So we still have like 3 students never done it yet. It's due almost 2 weeks ago. Then we make it to last week, and it's still there. So most of the commands that they're giving to you, and here these are the simple command you are going to. So they give you this information here, and you are going to create the database. Then you create the tables for this information. You are going to get 4 tables here. That's what they said. Now, if you go to well, let me go back. If you go to the classroom, you'll see we have 4 files here. You are going to put all the data for animal TST into the animal table, visit into visit table, billing, then owner. Because when you read the instruction, that's what they are saying here. You have to create animal data, then the billing data, owner data, you put the information in the right place. That's populate the tables with the data, which is the Excel file is here. So you are not doing any join, no subquery. It's just what we learned from module 1 to 3. You're just going to write a simple select statement, create a query to display the animal. So for example, here they say create a query to display the animals that visited a pet vet and got vaccinated. How do I do it? I'll write the select, which is the command. I'm selecting animals. So I'll say select, or they didn't give me what columns they want. So I'm going to say select all from animal. Select all means asterisk from animal, because the table name is animal. Then you look at the condition here. Display animal that vaccinated. So you can have where vaccinate. Again, I don't know the field. If animal, do we have vaccination? Animal breed, owner, birth. Yeah, they say animal that, oh, sorry, I'm saying vaccination. Animal that visited a pet and got vaccinated. So we look at visit. If we have any field there for animal ID, owner, name, birth date, animal type, animal breed. But we have the visit. There's a relationship between animal and a visit. And now when I look at the visit table, I have the animal ID. Okay, so this works. And here they say visited the pet.
Professor, sorry to interrupt, but I have a class like right now.
Okay, yeah, you can leave. I almost finished. So again, that's what I'm trying to explain here. Just follow the steps here. Again, if you haven't done it, make sure you do it. So I'm going to end the class here if no question.
Professor, I have 2 questions. Maybe, yeah, just 2 questions.
Yeah, go ahead.
Well, it's not really a question.